Cool. 498. Diagonal traverse. A traverse. Given a matrix of m by n elements, return all elements of the matrix in a diagonal order as shown in the below image. Okay. That's kind of cool though, because, well, because that's like literally, like, yeah, wasn't that the proof for diagonalization of rational numbers, something like that? That's how you like write it in that order. Okay, it's not important to this problem, but that's annoying. Uh, mm, okay, so basically, yeah, exactly. But it's not that important, or at least like for solving this. Uh, and I guess you don't go back and forth technically. I mean, I guess you could write it both ways. Depending, the ordering doesn't really matter within the diagonal. But okay, I mean, it's just some weird. I think it doesn't tell you what happens when m is not equals to n, but I guess that's okay. Uh, shouldn't be too bad. It's famous last words for these kind of problems. In theory, but you start with okay. So let's say you have some k, which is the diagonal row, if you will. Maybe I shouldn't say that. The diagonal number, and that's in, let's see, m plus n, right? Well, it's either m plus n or m plus n minus 1 or something like that. Yeah, 2, 3, 4, 5. Yeah, so that's m plus n minus 1. Oh, wait, which one is? Okay. Just want to use the same language. What? Like, I have to. I always forget. I feel like I have mental notes, but then sometimes I end up at the end forget to type them. So let me just do something here. I guess I should return nothing because then there's no element anyway. But okay. So that's inclusive, so that's this plus 1. I'm just going to leave it like this for readability, kind of, maybe. It's just a reminder. Maybe I'll clean up later. But for now, it's a reminder of why I did it this way. And then now you start with, okay. So you have x is from 0 to k, and that's k plus 1 for inclusive. And then y is equal to k minus x, right? So now you just print the, yeah, something like that, right? We saw that append xy or something. It's something like weird. I mean, this is roughly right, but not really. It's that. And then, well, if k mod 2 is equal to z, or maybe, or the other way around. I have to print it out to see. But, oops. I think something like this. So you have to bound check and make sure a lot of stuff is start from the right one. Maybe this is not from 0 to k. Something like from m to k or something like that, depending on, again, which mod 2 you're in. Because you also don't want it. Maybe it's okay. All right, let me do an IFD first. And then and after this, I will, because I think you could clean this up for sure. I just want to see if this is okay. Oh, actually, I already have M and N. So this would definitely be not the most efficient thing, but I just want to print it out to see. Okay, so I think I did them backward, but this is mostly right, except for that swap the order. Oh, yeah, that's true. But I think I just like to keep it there. Okay, so I did get it right. Um, you could probably be more efficient by noting that, like, you start at 0, so it would start like for here, it would start at like here, which I think for 10,000 elements may be a little slow, maybe. Like it could be, that's like at most 2 times more, so maybe that's not so bad. Yeah, because if you look at the diagonal, you have the square at like almost like a diamond, and then you have 2 triangles that you're extra. So this is still linear, just 2 times linear, so it's not as efficient, but maybe I'm okay. Maybe I'm lazy. I want to get rid of this triangle. Because right now I start at 0, but what should I start at? Let's see, on the second row, we should start at, I guess M logs in, so if it starts, but then you have to do this thing up here, so I'm a little lazy, so I'm just gonna submit this. Oh no, is that it? Well, I guess I should test a couple more first, but I thought I checked the bounce. Did I? Oh, maybe I checked the wrong bounce. Oh, because I swapped the X and Y and then, oh, sad face. And because it's no longer square. I guess if I had tested any non-square example, this would have failed, but I did not because I was lazy. So I just have that incorrect thing. But yeah, it's still right. But okay, fine. Is that all? Let me try an empty case. Now I feel a little overcompensating, but whatever. You know. And maybe just a long line. It's not that long, but because my typing is terrible. Oh yeah, that's good that something came out there. No, I'm wondering why. Did I fix something incorrectly? By double count? I guess so. Did I get it right? I'm just. It's like a diagonal thing. Maybe I okay. Wow, I'm consistently wrong, but why? Dun, dun, dun. Why did I count one choice? Okay, it's good that we test then. Maybe I double counted a row on the loop back. Yeah, I double count on the as a result. Do thought I was not gonna lie, I thought I was relatively confident, but it's not. It's either that or something Pythonic that I messed up by accident. Because I feel like sometimes, like, I have a negative number somewhere, like this, and then like wraps around and I've accidentally did not pay attention. Where in other languages it'll just tell you you're doing stuff out of bounds, or like you have a negative index. That's not cool. Okay, great. I'm gonna restart. Let's print some numbers out. Oh no. Okay. The XYs are what I would expect. So why is it? Why is this one? Oh no, this is one. But why is 111? One of the. Just real quick. It's true, but K is the same, right? Why would it print that twice? Or hmm. Like K is. Oh man, I'm just dumb. Okay. I think I just got lazy, and then the shorthand is eh. Also, yeah, okay. Yeah. Well, yeah. Okay. Silly mistakes again. The logic is right. Okay. All right. Come on. Oh, time makes it really. I actually didn't think it'll be that long because that would be at most two times longer. But I guess I was wrong. Well, I don't know what I'm testing. Okay. So we just have to start this a little bit later. Let's see. Given M and N, you want to start at. Okay. I guess this actually matters for. Oh, did I get this correct? So, 1, 2, 3, on 2, 4. Just to be M maybe? Either M or N, I suppose. And now you don't need this if statement in theory. It's actually, no, that's not true. Well, maybe. Maybe that's the tough part. Again, I possibly underestimated this form a little bit. Oh no, it's going to time limit. I should have tested. I just want to test it for a small example first. Oh, that actually went in time, though not correctly, but oh, because I didn't test the other one, really. So when we'll store that at a maximum. So to make sure I get this right now then. Which is okay. If this is even number row, okay, then the row starts first. And we skip rows to the end. Oh, let's just do half of them at a time. Oh, that didn't work. But, so we need a quicker case. This should go from N to M or something like that, maybe. But that doesn't really fix it, though. Right? Those are Y's first, so let me do it this way. See. Because Y can be at most oh no, that's not the row. Oops. Instead of 4, 0, we just write our value. We want to start 3. But, that's minus, it's like minus M or something, right? So if this is bigger than M, yeah, if this is bigger than m, then the delta is actually k, I guess. So if k is bigger than m, then you start with m. Okay, so and then where you end. Max of k of m, something like that. Maybe something like that. No, you have some stuff. I'm going to try not to look at it for a second. I'm going to try to figure this out myself because I definitely should have figured it a little bit. I was just a little bit lazy. Okay. It's like a -1 somewhere maybe, or +1 somewhere. Just point this out first. Yx in this case. Sorry. Actually going to try to solve this, but I appreciate the help. I saw some maybe I've hit over hint, but I'm not trying to not look at it. Oh. So this is right, and then there should be 1, 1. Nope. Should be. This is for k goes to 1. Maybe why do I have this? Yeah, I thought it should have, but I don't know. Maybe I do something too funky. Well, yeah, I don't know. I think maybe I've done something n squared by accident. No, but it's total elements, right? So yeah. Oh, I think yeah, because I think it's 2 to the n if it's a square, but if it's not, then you can imagine that like one of the edges 10,000, so then it end up being 10 squares, so it shouldn't have worked anyway. I was just a little lazy and I messed up the analysis there. But okay, k00, so this is -1 maybe, something like that. Or maybe I just have to wait. Oh, that's just wrong. Alright, I should actually have thought about this instead of just playing around with too much. Okay. Well, the max is wrong. Should go to k, but then it's k plus 1. Okay, this is more right, maybe? 0, 2, 1, 1, 3 is kind of wrong. But, off by 1. So 4 also wrong. So, rid of k and m. I confused myself by iterating the weird way. Okay, so 0, 2, 0. Why is this 4? Because 4 is k. No, but m is. Well, m in this case is just 3. but then it goes to k plus 1. Man, these problems are always these problems are always annoying. Okay, so you want this to go, but like the min part's right, the max part is not right. What do I have? Do I have something like this? Maybe a bit. Guess that's wrong. This goes to okay, so also this needs to iterate 2 times. Okay, first principles. I think the main part is right. Is that true? 2? No, because it should always be, well, this should be just minus 1 maybe. Because you have to get the last row. Maybe that's, I think that's a little off. Yeah, then you get 2, 2 as well. But now we, okay. This is more right. How do I get the more? Man. How come I'm skipping 1, 1? Oh, because this is on part 2. And this isn't going enough. It starts at 2, 0. So it starts at 2. So it cannot go to 3. Okay, so maybe I did it backwards. Okay, that's slightly better. Except for this is wrong, but okay. So the max is right, but the min is wrong. Maybe. Well, the min is goes from 0, 1, 2, so it should, where should it start? the X position. I guess we should start at 2. Maybe there's some like that doesn't make sense. Man, I hate this file. Oh my god. I think what I needed actually, I think maybe in real life I would do better if I had a whiteboard and a white paper. Well, I guess I don't need whiteboard and a white paper. I just need one of these things need to be black, but I'm gonna play around with a piece of paper in real life. Yeah, I don't even have a pen ready, to be honest. That's a little embarrassing. I have markers though. Give me a second. Oh man. The idea is mostly right, but that's not good enough. I think the hard part about doing the stream is that a lot of the times I'm trying to keep everything in my head. I think sometimes it's hard, especially for these kind of visualization stuff. But so basically you want, so for 2, right, and for 4 you want M to be, you want M to be 2 at most. Also confusing M and M's a lot, so I should actually do another example. Just for start to do. Yeah, because I think I tried too fancy. I think I don't need any of this explain stuff. Maybe I could just do something like, okay, X starts at, okay, if, how do I say it? X is equal to K first. Okay, if X is greater than M, then X is equal to M, right? And then while so then it just keeps on decrementing, which is true. Well, maybe not this. Also maybe not this. Okay, so then Y is equal to K minus X. Okay, so now we have a coordinate. And then, well, Y is less than N, right? I try to be too cute, maybe. This is not right, but so this goes 1 and this goes. Right. So X goes down. Nope. Okay. Yeah. Should be before, that's why. Get my index one. This should be. No, we can actually. This should be cleaner as. Okay. Promising. Sorry, friends. Sometimes these things are very annoying. In fact, maybe often. Okay. Now you want to go the other way. So let's have the Y. Okay. Wow, it took 25 minutes for me to figure that out. Okay, well, if you're still on the stream, thanks for staying with me. Oh my, I think there was a lesson to be learned here. Is that I don't know. I need to have a plan. I think uh, I think for me the kind of what got me a little bit is that I felt like I was so close. I was just maybe off by a little bit here and there. I keep on like throwing things to just kind of maybe hopefully get it to be right because everything felt so close, you know. But I think what I had to do and what I ended up doing was kind of resetting myself and then asking myself, okay, is there another way to represent this? Represent kind of what I was thinking, and that's how I end up with this kind of thing instead of keeping in one for loop, and just yeah, and I think for me it's just articulate. I can't even. I was trying to say the word articulating, but I can't even articulate the word articulate. But for me, yeah, once I kind of reset myself, even though it took me way too long, 25 minutes to reset myself, to be like, hey, um, like what is their starting point? What's your ending point? Well, my starting point is, uh, just instead of, because my initial thing was like you have a whole uh, diagonal and you start at the base where x is 0 or whatever it is. But what if yeah, but then once you're past m or n, depending on which way you're going, then x can only be m, right? So then you only move that up, and then you have to move y to corresponding distance, and then I have this while loop, which is, I mean, once you get that logic, it's very obvious as we kind of just shifting. Yeah, it's kind of like summation. I think it's still. I mean, I think mathematically it's relatively the same in the sense that like I both did, like they both are the same. I think I could rewrite this now as a form of now that I know the answer, a little bit. But because you could, replace this with k minus x and so forth, right? and so you could definitely rewrite this as what I did before. But I think my issue was that I was trying too much to kind of I don't know. I think one of those things is that when you have so much, I don't know, when you do a lot of problems, like you trust your intuition a lot. Uh, that sometimes when your intuition is just a little off, you're still like oh, maybe I could use intuition and get my way out of this, but I did not. So I had to kind of reset myself. I wish it didn't take 25 minutes though. I feel like I could have done it much faster because I had all the pieces and I was very close. At the end of the day, it was that like I was, you know, I could have changed the indexes, but I think I had to recollect myself a little bit. Yeah, yeah, exactly. Like I should have just changed it a little bit, but I think I think the code in this case is secondary, right? Like I mean, like we could definitely write what I had before, or this in terms of what I had before of X range and so forth. I think it's just for me, I was a little stubborn, like mentally, about like how to approach a problem, and I got stuck in a what where like I needed to kind of think about it myself. Okay, it's like step back and ask myself, okay, what am I actually trying to solve? And I think when I finally did that, then I was okay. Huh? Oh, that yeah. Oh, oh yeah, yeah. That I kind of I think maybe there's a cleaner way to do inclusive. I mean, I know that obviously this kind of evens out. Like I'm not, this is very obvious to anybody. I think, but I think for me it's just like the way to show that I want it to be inclusive on this. Uh, but X range, you have to do a +1 to be inclusive, if you will. But you know what I mean? I don't know. Because like I like if I were to do it in another language, which is maybe my Pythonic, but like I would do like 4K, is equal to I, zeros I, and then you like, so that's the difference between like less than and equal to and less than, right? So I would make like less than and equal to this, so it's clear what I want, uh, and I don't know, it's a maybe I could have added the parents, but yeah, where like yeah, in a weird way. And I think maybe, no, I was going to say maybe you could use constants, but that doesn't even make sense for this because this is just like, these are just the or offsets or shifts. Uh, but yeah, it's a little weird. Like if there's an X range type thing that is inclusive on both ends, or closed, if you will, closed range instead of open on the right side, and that's what I would try to do. And if there is, definitely let me know. I need to do better about Python stuff. But yeah, I think like this was for me. Like most of it was just a mental thing. Like I got most of this pretty right. What was this again? I don't remember anymore. It's so long ago. Oh, I just assumed they were squares. Uh, and I even did my analysis wrong because I thought it was going to be 2 to the n. That's why it wasn't going to end of time. But that only assumes that it's a square matrix. Once it's not a square matrix, then my other algorithm, you need to skip ahead or end early, depending on which diagonal you're on. And I didn't do that, so that's why I was kind of, well, not good. Okay, cool. Was that the first medium? Oh, man. No, I didn't actually really talk about this farm. I just talked about my retro, which is fair. Let me talk about this farm for a second. But yeah, this is now O of n because you always start at a cell and you end at a cell, right? Uh, so yeah, so this is O of n in terms of or it's linear in the input size, again similar to the algorithm, depending on who you ask. But this is actually O of m times n, which is maybe a tongue twister. Say that 10 times fast. But yeah, so it's linear in the input size, which is m times n, and space. Well, I mean, it's again same as the other problem, which is that it's output sensitive, so it's O of m times n again, because that's what you're outputting. You can't really do better than that, and O of one extra space, so that's also good. Non-output sensitive space. But yeah, and I've definitely seen these kind of problems on interviews before, for better or for worse, which for me maybe is for worse, not for better, clearly, as you see. But maybe with just some practice, it'll be for a little bit less worse. But so I definitely recommend kind of practicing this. People really like to give these kind of problems for some reason. I think there's some merit in that, um, and because it really tests the concept of invariance and stuff like that a lot of the times, and invariants are kind of a core principle of a lot of CS fundamentals, and actually comes in handy with for loops and stuff like that, because you're going to write a lot of for loops and there will be invariants, and so this is the real world thing, even if this is maybe a couple of steps abstract away uh, uh, from what you would do in the real world, but proving invariance is kind of tricky sometimes, or like like knowing what the invariant is. And in this case, for example, the invariant is that x plus y is equal to k, for example. So we could kind of just have one loop instead of two loops, right? But yeah, I mean, definitely. Oh man, I struggled with this one, but it was okay. I mean, I like eh, like I said, the last 10% took 90% of the time or something like that, right? So yeah. But that was okay though. Like I mean, I think it's good that I practice it. So that's